Hello and hi and welcome back to chapter 7. This is called controlling access to files. Let me just go through the intro really quick and I'll be back. Yep. There's a bit. That's me. So that's quite enough. So we're going to chapter 7 right off the bat without any hesitation, and let's go right to it. And before we do that, we need to go through a couple of concepts here just to make sure that everything goes according to plan. So we need to just review a couple of concepts but strap up, because this one is going to be a longer one. You need to discuss some things before we actually get your hands dirty. So let's dive into some concepts and we should be good to go for all the rest. So do not forget, our mindset for this chapter is file permissions, folder permissions, and all of that good stuff. There are two main things to cover about permissions. We have standard file permissions and we have access control lists. Access control lists I will cover when I record the RH124 content for that course. So stay tuned, like and subscribe for that. But for now, let's discuss some theoretical concepts around permissions. Let's dive right through it. I'm going to discuss with you guys a concept called, it can be very deep. I mean, any concept can get very deep, but this concept is called the inode. Okay, this is going to be a very superficial inode thingy right now, just enough so that we can understand enough so it makes sense when we discuss the actual file permissions. Okay, so what is the inode? Any file system has this, like Linux or any other. So the inode kind of have some file properties. Okay. So file or folder. When I say file, folder also applies right here. Okay. So the inode has some properties about a file or folder. And for example, I will give you some examples. This is very generic. Okay, not really specific, not a deep dive around inodes. It has its name. Okay, like file name. Okay, it has these attributes. Like, for example, it's mutable, non-mutable. I will not cover attributes right here, but it are also some file properties we can actually discuss. You can have other things about the file, and in the end, you have also the file permissions, which is what brings us here. So file permissions are also embedded in some way or other on the inode or in the inode. So the inode has the kind of the profile properties, our folder properties. I'm not discussing the full gamut here, but some of them, which will include also the file permissions. Okay, so the inode, we have discussed inodes when you discuss hard links and soft links. Just check that chapter and you can see a little bit more about that. But for now, you kind of know what an inode is if you were checking all the series. If you don't, now you know. It's all file systems have an inode or multiple inodes, and that includes the file properties, attributes, and all of that good stuff. You will understand in a second how this applies or why this applies to this subject with these file permissions. So you have inodes. So the inodes have all of this good stuff, and this is where you can find all those properties. So also the permissions. So which means the following, something to be aware of. So we'll come back to the inodes in a second, okay? But when we talk about folders, and this is kind of important, folder-wise, and we'll come back to this in a few seconds or minutes after discuss a couple of other things. So, for example, let's say you have a folder. Let's put here a rough representation of a folder. So you have a folder. So the folder, let's say, will have its own permissions, perms, and we'll discuss permissions in something more specific in a second. But don't just just bear this in mind. Folder permissions will also have an influence on the files the folder contains. Okay, so folder permissions will also have an influence on the files the folder contains. So this is going to come into play in a few seconds or minutes when you discuss some other stuff. But don't forget that permissions on the folder will have an influence on the file it contains. Okay. With this in mind, let's check out some other piece of information. So I'm here back on my Rocky servers, and I'm going to focus here for a second on Rocky 1 or Rocky 2. It doesn't make any difference if it's Rocky 1 or Rocky 2. But let's focus on Rocky 1. Let's check our current location. So we're in a root folder, which is fine. And you have here a random file. That's fine. Let's just create a random folder, mkdir folder. Okay, and inside that, let's just create some files. So if you remember correctly, the touch utility allows us to create empty files or allows us to change the timestamp of a file. So let's create touch sample file, sample file.txt. Okay, and let's also create a folder, mkdir sample folder.txt. Okay, so we are good to go here. Cool. Why did I give the sample folder txt a txt extension? I don't know. It's still 6 a.m. so I'm kind of brain rot right now. So let's just remove that just to make sure that I'm not looking this in the wrong way. And let's create this as a sample folder. Cool. Now this is enough for the full discussion for now at least. So if I do a long list here, you can see that these files have properties around here and properties around here. And this is what I'm going to take a sample image of, and I'm going to work with that. So let's sample this part of our information. So let's put it somewhere here. Let me find this on my document. I pasted it, and it usually pastes this on to random location. That makes no sense. So better with me a second while I pull this in somewhere else. This also pastes in something really weird. Cool. Now we have it here, which is awesome. Now let's go back to our notes, and we have here the sample of the file system. So now we have here some characters that will represent stuff, and this is what we're going to interpret. So right here on this column here, blacks, it's fine. In this column here, you have a dash and you have a D. So dash means file, regular file, regular text file, regular executable file, and D means directory. Okay, which I think most of you guys already kind of got the gist of it. But these are not the only two. You will see, for example, you will see B for block. Block device usually random main storage, hard drives, SSDs, whatever. We'll cover that in a later chapter. This is a block device. Then we have also C, which is character device. Character. I'm sorry about my handwriting. It's too late to fix. Character device is something special, like the DevNull and other special devices that we have in the system, like the random, the urandom. Don't worry too much about all of this, because this is something we'll discuss while we go. And something we also know, which is the L, which represents a soft link. Okay, so file, directory, block, character device, and link. So that first character tries to identify to us what this file is all about. Okay, then we have, let's change colors for a second, all of this block of information. So all of this block of information represents the permissions, which is the thing we're going to discuss here, which are the permissions, well, the sender file permissions. Here we have this is a full stop, and at this time, this is actually a full stop. This means absolutely nothing special. It's just kind of at the time the way they managed to represent, okay, all the file permissions end here. Okay, so there is nothing else to see. You are at the end of the file permission set. There's no more to see. It ends here. As we progress on our training courses, and as especially when we reach the RH124 training, you will see that this represents some other stuff, or can represent some other stuff. But we will, for now, stick with this. So this is the kind of the dots. This is the end of what is there to see in this type of context. There's nothing else to see. Here we have we have discussed this. These are the hard links. And then we have here two columns which represent, this is the group owner. I'm sorry, not a group, sorry. The user owner and the group owner, okay? So this means that root is the user that owns the file. Root is the group that owns the file, okay? So user root is the user that owns the file, and root is the group that owns the file. So as you guys already know, at this point, we have discussed user creation and group creation. When you create a user, he is always part of his own group, okay? And the reason being is that when you create a new file or folder, then that file or folder belongs to some kind of group. It's not kind of homeless in that matter. So if you go back here, this represents 3 groups of permissions. This is the permissions for the user. The second one is the permissions for the group, okay? And the other one is the permissions for the all the others, okay? So that's why many times you see this represented as UGO, okay? The user permissions, the group permissions, and all the other permissions. So this is kind of how Linux file system permissions are set for the most part. The other ones can be as access control lists. We will discuss access control lists later on. And also we will have something called the thing called SL Linux. We have not discussed yet SL Linux, but these are the 3 main things that can influence file access. The permissions, which we are discussing right now. ACLs we will discuss later, and Linux and SL Linux that we will also discuss later on. So all of these 3 can influence file access permissions. Amongst other things, but these are the main things we should consider first. Standard permissions, which are the ones we're discussing right now. Standard permissions, access control lists, and SL Linux permissions are the 3 that can actually influence how a file is being accessed or can be accessed by a specific user or group. Pretty great. So pause your video here if you want to kind of check it out. I'm sure that most of you guys are watching this at 2 times speed, which is it's also what I do, and some people are watching in half speed. That's all fun. We are all different, and yet we are also good people. So let's discuss what those letters mean. So we have 3 main letters. Oops, sorry. We have 3 main letters, which are the R, the W. Oops, my handwriting is horrible. Always has been. RXXX, and this means read. Come on, I can do better. Let me try this again. So read, write, and execute. Okay? So read, write, execute. Even though they look a little bit kind of what you see is what you get, let's discuss this in terms of if it's a file or if it's a folder. Okay? This will represent different stuff. Okay, file. If it's a file or if it's a folder. So I will give you 3 examples. An example of reading a file is, for example, doing the cat, doing the more, or for example, doing the quit without saving. Okay? That's kind of using VI or VIM to access the file and exiting without saving any part topic information. So that's right. Read. Write, it's to, well, for example, going back to VI, doing the write quit, so saving the information to the file, doing some redirection. For example, it's also an example of writing to that file. Now let me just I will just pull this a little bit up so you can see behind my camera. So what the other one is execute. So execute, can you see here? You can see here. Execute means something like it's a binary file that you can set it as an executable, or it's something that is converted to a script. We will discuss scripts on the RH124 course, so like and subscribe to get notified about that. So we have a text file that is converted to a script. It's also resets the execute permission. Now, if you focus in a folder, read a folder, for example, it's to ls the folder. Pretty simple. Write to the folder is to create the file within the folder or change its contents. So if I create a file within the folder, okay, it's writing to that folder. Okay, so I am creating a new file within that folder. And remember where we started when we discussed the folders and the inodes. You'll see that this is going to come into play in a second. Then you have the execute permission. The execute permission can be the kind of the weirdest one of all 3 when applied to the context of a folder. but the execute permissions of a folder is the capability of doing the CD into the folder. Okay, so I can only CD to a folder if I have the execute permission, which is kind of weird, but it's the truth. So to read a folder is to ls its contents. To write to a folder is to create a file within that folder. X is to CD into the folder. You usually say CD into the folder. It's not actually very precise or correct, but it's not that bad actually. So, which means that in some sort of weird combinations, we may be able to CD into the folder if you have the execute permissions, but we cannot ls if we do not have the right permissions. Okay, so this can happen. So I can CD into the folder, but I cannot list its contents, which is kind of weird, but it can happen. So I can ls the file contents, but I cannot CD into that, or the other way around. Or I can copy files to that folder with the absolute path name. I can put files there, but I am unable to confirm the file is there because I cannot do the ls and I cannot do the execute. Okay, so these things can actually happen if a specific set of permissions actually are applied to a folder. See where I started, so this makes a little bit more sense. So the folder's inode has some properties, the file inode has other properties, and the folder inode can actually be very, very powerful. So these are the kind of the permissions you can expect: read, write, and execute for a file, read, write, and execute for a folder. Keep this in mind, because this can mean something like this can happen. For example, let's say the file, this is kind of, let's call it Bob. Okay, this folder belongs to the Bob group and belongs to the Bob user. So Bob is the owner of the folder as a user, and the owner of the folder as a group. So Bob is kind of the group, the set permission set for the folder. Okay, and let's say that Bob, the folder permissions are rwx, which means let's put just not so good here. So let's say the user has full permissions, the group has full permissions, and the others have read permission. Okay, so don't forget this is Bob, and the others have only read. So nothing special here, right? So let's also say that here we have a file called file.txt. Okay, and this file.txt is owned by Alice. Okay, and the permissions are full permissions to Alice. I'm sorry, let's try this again. Full permissions to Alice, and the others have only read, which is also very common. So Bob has full permissions on the folder, Alice has full permissions on the file. All the others have only read. And looking at this, you may believe that, well, before I give you the answer, give yourself a couple of seconds, and the question is, what are the permissions, what are the Bob's permissions over this file? Okay, my question is, what can Bob do with this file? Give yourself a couple of seconds. I will not cut this video out in any way or form. You are watching this as it is. So if I do any mistakes, you will see them. Are you thinking about this? So what are the full Bob's permissions? Okay. If you feel that you need it, you can have a coffee. So give yourself a couple of seconds to think about this. So what you think, what are the full permissions you think Bob has over this? So if you wish, take yourself a coffee break and have a thought about this. So yeah, Bob has full permissions on the files, even though it has, here it looks as if I don't forget, I can do an example when you just jump into the console next. If I forget, just comment down below and then remind me, and I can do a separate video about that, even if it's a short video. So even though the file itself has only reads to the others, even though the file has only reads to the others, since Bob has full access and full power over the folder, he will also can make forced saves on the files that are within the folder. So even though Bob apparently only has the other permission, which is fine. I mean, it's okay. Even though Bob only has write permissions effectively, since he has full power over the folder, he can force himself over the files and also other folders within the folder. So Bob has power over the top hierarchy of all this. He can force himself throughout all the files within that folder. And that's one of the reasons why the root user can actually force saves everywhere on the file system. That's because, root has permissions over the root folder, so he can force himself throughout all the file system. So if a user has full permissions over the top folder, he can force himself on the corresponding files and folders within that folder. There are some consequences to that, but he can. There is one way to avoid that, which is a special permissions called the sticky bit. We'll discuss that in a second. I'll tell you this chapter will be a long one. So if you set the sticky bit properties or the sticky bit value on the folder, which is the sticky bit applies to folders. If you apply the sticky bit to the folder, then what it represents is that even if you have full access to a folder or its contents, you can only delete what is already yours. We'll discuss this later on. So if you want to avoid that Bob does this, you should set the sticky bit and a couple of other steps, but the sticky bit should be the one you should be looking for. Okay? So let's jump into the terminal. Okay, and let's start to get our hands a little bit dirty, because if you understood these previous concepts, feel free to rewind. Feel free to come back to the previous part of the video to check all the details out. All of this that comes after that should be, I won't not say easy, because life is never easy to anyone, but it could be a little bit more better for you to absorb that information from this point on. Okay, so let's go back to our files. Let's just clear this and do a long list. So there we go. We have our folder and now have our file. If I list the long listing, you'll see all these properties, read, write, and all of that good stuff we just have discussed. Now, let's imagine you want to change, for example, the owner. Okay, so right now the owner is root, the group owner is root. Let's say you want to change this for some reason, and you are entitled to. So you can do this in two different ways, at least two different ways. Don't forget that there is always more one than one to do the same thing. I will not specify all of the ways. I mean, that's pretty normal, but I will show you two. So you can do two commands. One is called the change owner. Okay, so let's say I want to change the owner of the file. I forget which users I have here available, so I work with so many machines, I forget. So let's check the possibility file. So, okay, I have student, I have Alice, and I have Bob. Okay, so let's go here again. So let's do the change owner, and let's say I want to change the sample file. Oh, of course, before that it's the owner, the new one. Let's say Bob sample file. Okay, there we go. Now if I go back, now Bob is the owner, so I did it with the change owner. If I want to change the group, I can do the change group, and I say Bob can sell. Let's check the groups. Let's check the groups also. See group. So let's call sec admins. That's fine. So let's use this one. So let's do change group. We just paste or type the name and sample file. There we go. So I have made by using these two commands, I can this changes the owner of the file. This changes the group of the file. Pretty simple, nothing too complicated. It's pretty straightforward if you ask me. So going back here. Now, if you want to be more pro, you can use only the change owner command. Okay, if you want to be a little bit more pro, you can do the change owner command to to do both. So can do something. Let's say I want to put it back to root. So I can do root column root sample file. Okay, this changed both at one sitting. Or you can do column and the other guy, which is sec, I forget, sec admins. So I'm hitting the tab key to complete to get some hints. This changed on the group. Okay, so if you use a change owner, you can use the user column group technique, and you can change one, the other, or both at one sitting, or you can use the change owner and change group commands separately to change both. So both of them are correct. Both of them are just fine. You can just choose one or the other, and it's all fine and dandy. So right now, root is the user that owns the file, and secadmins is the group that owns the file, which is fine by me so far. Now let's change these guys there, the effective standard permissions. Let's change these two right here, which is fine. So here I have two options. I will start by the I call it the alphanumeric. It's not correct, but alphanumeric. Some of you guys are just cringing right now, but it's fine. Just comment down below if you are cringing or not. But he's using the actual letters. So let's do the command to do this is the change owner command. Okay, the change owner command will allow us to change the own. I'm sorry, I'm dumb. chmod, that's the right one. So we will use the change mode command to change permissions. Okay, and then you can do something like, for example, let's say I want to give the root user the execute permissions. I want to give root the execute. What I do is user, give it execute, and the file name. I'm using a file as an example, but you can do it on a folder. It's the same thing. These commands I have been showing you guys. It's the same thing for a folder. It's exactly the same thing. Okay. So there we go. The root user now has execute. Not too bad. If you want to give it out, if you want to remove it, you just need to remove it. There we go. The first one gave the permissions. The second one actually removed the permissions, and it's all fine and great. Now, if you want to do something for the group, you can do like this. If you want to do for the others, you can do like this. If you want to give it to multiple people, you can do user group. You can do user others. You can remove, and you get the idea. It's very visual. It's simple. It's kind of what you see is what you get, and you're good to go. The other one that you probably saw people doing is the chmod and doing some crazy numbers. That's the binary method. Let me explain this, how it works in a second. So the binary method. It's as follows. So we need to kind of understand a little bit of how binary works. I will not give you a throughout explanation of how binary works, but I will give you the simplest part, the enough for you to understand this. So let's represent here 3 bits. Let's put 1, 2, 3 bits. Why 3? Because we have read, write, and execute, so that's enough for our intents and purposes. So we have 3 bits, and each bit represents the kind of permission. Read, write, and execute, which is fine here. Cool. Now what we do here is just to activate the bits we want. Well, I just said it the other way around. Deactivate the bits we don't want and activate the bits we do want. And remember, and you need also to remember, it's decimal value. It's a decimal value. So let's say we have the 3 bits, and this is worth 1. This is worth 2. This is worth 4. So it's just a matter of doing combinations of this. So let's say I want to do read, nothing. I will activate this bit. I will deactivate the other 2, which means it's 4 plus 0 plus 0, which is 6. Wow, I'm really bad. 4, of course. Jesus, man. Okay. So let's say I want to do write WX, activate, do not deactivate. And this is going to be 4 plus 2 plus 0. Now we have a 6. Let's say I want to do 111. This is 4 plus 2 plus 1, which equals 7. And I think that's all of them, except of course the activate nothing, which is obviously nothing. So this is how it's done. Let's go back to the console now, so we can actually see it. So I can do something like, let's say the end result is read write nothing, read write nothing, read nothing. This is what I want to obtain. So I can do ch mode. So if it's 664, and the file or folder, and result. Okay. Let's say the result that I want is like this. So then it's going to be 644. There we go. Let's say I want to make this like this. So which means that the others will just get the 0. See, I think you guys get the idea. You probably have seen also a fourth number, like 2640, 2644, whatever the case. That's extra number on the left-hand side of the permission set. Represents a special kind of permissions, but we will discuss them in a second. Okay, they are called the set user ID, set group ID, and sticky bit permissions. We will discuss them in a second. And right after this, we will discuss them, and that's why we will probably see a fourth permission number around on the left-hand side. You don't usually see it, but you may see it. But you'll understand what that means in a few moments. Take a breather. Take a breather. Do you have any questions? Ask them down below. Feel free to do so, and I am happy to oblige. All right, let's carry on. So let's go right there. Let's discuss the 3 special permissions. They're called the sticky bit. I can do this in the PDF. It's kind of, let's go here. Cool. Now let's discuss 3 permissions. One is called the set user ID. The other one is set group ID. And the other one is the sticky bit. Okay, the one that it's kind of more harder to digest, the one that it's a little bit harder to digest, it's the first one, because the other ones are just a little bit of a consequence of the first one, which makes it a little bit make them a little bit easier to digest. So let's discuss the set user ID first. Okay, so listen to me and rewind this if you have to understand this fully. So basically, set user ID, it's something that sets a file, okay? File permission, this is not a folder permission. If you can apply this to a folder, but it will do absolutely nothing. So set user ID means when a user executes this file, the file will execute with the rights of the owner and not with the rights of who executed it. Example. Let's say I am the student user. If I execute this file with this permission set, if student executes this file, the file will be executed as its owner and not as student. Again, let's say that this file belongs to the root user. And this applies, once again, this only applies to files that are executable, binary executable files. If the student executes if the student executes this file will be executed as a root and not as the student. Okay, so this file is owned by the root, and student executes the file. So which means that if student executes this file is going to be executed as root, which is the owner, and not as student, that is who executed this file. This applies to binary files. So this file will be executed as its owner and not has the one who executed it. Sounds weird? Yeah, it sounds weird as F, but let me give you an example. So let's think about some stuff we already know. So we know, let's consider this. So you have a file that contains the user's passwords. That file is DTC shadow. Okay. Okay, DTC shadow file contains everybody's password. Cool. That's something we already know. Let's also think about something like this. Who can change the password? For example, is student able to change his own password? Is the student user able to change his own password? Yes, he is. Everybody is entitled to change their own password. But if you check the permissions of the shadow file, you'll see that the shadow file, you know how to read permissions at this point. You see that the shadow file is completely inaccessible by everyone. Okay? It seems that nobody can change it, but the only one that can change the contents of this file is the root user. Okay? So the root user is the only one who is entitled to change this file. Even though it doesn't look like it based on what you see there, which makes sense for you guys right now, there is a kernel tweak that they have applied that says user can change. The root can change. Only the root can change. Even though it's not specifically explicit on the file system, the root can change. The root can change this file. Okay? But you also know that any user can change its password. For example, the student user can change his password. So if only the root can change the contents of the shadow file, how can the regular user change his own password? Let's think about something else also. What is the utility to use to change the password? So let's say the student user wants to change his own password. What is the utility he uses? He uses the passwd, right? That's right. So I am not student right now, but I could, as a student user, I could just change my own password. So let's check the passwd utility. Okay. And let's check its properties. Cool. This is the executable. It is executables in it because you see a bunch of X's. But you also see here an S. And the S actually means that permission that we just discussed. This is the set user ID. So the S on that position means the set user ID is set. Okay? That is pretty good. So this is the set user ID permission is actually set. Okay? Which is pretty nice. Now, since this permission is set, okay, since this permission is actually set, okay, means that this permission actually applies, which means a user that executes this file, okay, the file is going to be executed as the root, because the root is the owner, not as the user that ran the file. So since this permission is set, means that the user will execute this as the owner and not as the user. So if student executes this is going to be executed as root and not as student. That's why the student can change his own password, or Bob or Alice or whatever the case. So since this file is executable, because this applies only to executables, since this file is set as an executable, okay, and has this bit set, it means that he can actually change his file's permission. He can execute as root. So student executes this as root, not as student. That's why the user student can change his own password. I know this sounds confusing, but rewind this a couple of times and listen to this a few different times so you can actually listen to this multiple times. So the user executes as root. This file will be executed as root and not as student. If you remove this permission, then nobody can change this password because only root can change the contents of the shadow file. Okay? You may be asking right now, how do I do that? So I can do chmod user plus s and the executable. Now if I see this, now it's kind of a different color. The S is missing, it's not there, which means that Now, the set user ID property or permission is not set, which means that now only root can change passwords. Nobody can change their own password. And this can be your goal. You don't want people to change their own password. You want people to request root for that. And that's fine. To set this back, you do the U plus S, and this will now put everything back. So this is a good example for the set user ID permission, which says, I will say it one more last time. The set user ID permission says, when this permission is set to a binary executable, this will execute as the owner and not as the one who executed. So if student executes this file, the file is going to be executed as root and not as student. Okay? Rewind this a few times back if you wish to rehear this if you wish. Now the other one, it's a set user ID. I'm sorry, I'm dumb. The group ID. The set group ID, it has only effect on files, not on folders. And I mean, it depends really. If you set this permission on the file, we'll have one result. If you set this on the folder, we have another result. That's what I wanted to say. So let's say you set a group ID on the same file here. Let's do this as an example. So let's say you set a group ID, then you will see an S here. I can do it for you guys to see. So I can do, it's the same thing as the previous one. You just do G plus S. And we'll just appear an S here. And this will say similarly to the first one, but with slight changes. If you do this to an executable, now this file will execute as a group that owns the file, not as a group that executed it. So it's kind of the same phrase as the previous one, but applies to the group instead of the user. This is not very commonly used, but it may be. Okay, this is usually used on the folder. And if applied to folders, it says, before I explain, let me show you a folder. Let me see if I have one here, right? Yeah, I have a sample folder. So the folder has these permissions, root, and these permissions here. Okay. So if I create a new file, nothing special happens. This is very predictable. The new file here, it's owned by the user that created the file and the group that created the file. And that's kind of expected, right? Nothing really special here. Now, it's also very common in some situations that the user is the owner of the file, but some other group is the owner. So let's do change group. Let's say the student group is the owner of the folder. So now the student group owns the folder. The user root still is the user owner, but the group owner is some other group. If you create a file now, if you create a file now, you see that nothing really changed. Again, not too surprising. But sometimes you want to make sure that the group that owns the folder, also owns new files. So newly created files should look like the user that created, and the group owner of the folder also owns the files as a group. That's when this permission comes into play. chmod G plus S, the current folder. Okay, if you see an S here, now you can create a new. Okay. Now this means that the file I just created, now the group is also its owner. Okay. Now the user owner is root, but the group owner, it's a group that owns the folder. Okay. Then you can set the group's permissions accordingly. Okay. So that it has some different permissions. So in this case, you can immediately give the group owner also some special permissions of new files created within that folder. So GUID applies to files or folders. If you apply to an executable, it will be executed as the group owner of that file. If you apply to a folder, newly created files on that folder are automatically also owned by that group. This can be useful if you want to have this this group to also be some sort of admin of that folder, which can be quite handy. So set 3 special permissions. Set user ID will apply to executables. Set user ID will execute as the owner of the file, not who executed it. Set group ID, it depends if it's applied to executable or to a folder. If the set user ID is applied to an executable, it will execute as the group owner of the file. If applied to a folder, newly created files on that folder will be owned by that group. And the last but not least, we have the sticky bit. This is the one that you understand easily. Sticky bit means that even if a user has write permissions to a folder, he is not able to delete files unless he's the owner of the one who created it. Okay, so sticky bit, again, sticky bit means even if you have write permissions to a folder, you will be only able to delete files that you created. And give yourself a second and think about this. Do you know or remember any files, if you remember any folders on the system, on any Linux, that allows anybody to write to there? Okay? But you cannot delete every file. So in theory, if you have the right permission to a folder, you can also delete the files. Right? But can you remember any folders on the system that everybody can write to there? But they can, well, this is the first part of the question. So do you remember any folders that are on any Linux system that everybody can write there? Anyone? Do you remember an example of that? Think about it for a second. Do you remember any files or folders on any Linux system that everybody can write to there? So we can discuss the sticky bit a little bit further. If you thought about the var temp and the temp folders, you are correct. So the var temp and the temp folders are an example. If I go to the var tmp, you'll see that everybody, oh, wait, where is it? Oh, sorry, I need to put the A to get the green folder. So everybody can write to there, but if you check here, it has a T. T means sticky bit. So everybody can write to the var temp. Anyone on the system can write to the var temp, but I can only delete files that I have created. For example, the student user can write to the var temp folder. The student user can write to the var temp folder. Yes. Okay. So the student user can write to the var temp, but he can only delete the files that he owns, that he created. So even though everybody can write here, they can only delete what they have created, not everybody else's files, which makes total sense. That's the sticky bit. Sticky bit means you can only delete files that you have created or that you own. Okay, so everybody can write to the temp or var temp. This camera. So everybody can write to the temp or var temp, but you can only delete the files or folders you have created within that folder. Okay. So 3 special permissions. Ask down below if you have any questions. Ask down below if you want anything to be more further explained with more examples, or comment at all. Like and subscribe, and also it really helps the channel to grow a little bit more. Cool. Now, last part of this long chapter. I told you that this was going to be a long chapter. Are the default permissions. Okay, the default permissions. So let's discuss a little bit more the default permissions. Okay, the default permissions. Okay, what are the default permissions are as follows. So we have here, let's go back to our initial folder, which is a little bit more simple. So when I create a file, it immediately has some permissions. So this is not the case. Let me just remove this file because I want to create a fresh one. That's fresh. So I have just created this file here, and I have created this folder that I haven't touched the permissions. So when a new file or folder are created, when a new file or folder are created, new files have this set of permissions and new folders have this set of permissions. Why? Because the guy who set this up on the file system and who set up this operating system, which is RHEL and all RHEL based systems, so decided. So let me show a quick thing. You have a thing called the umask. Okay, so the umask has this set of permissions. So let me do first. Let me set the umask to nothing. Okay. Okay. So here we have the umask set to nothing. Okay. Now let's create a new file. Let's call it file fresh 0000. As you can see now, it has a different permission set from the fresh file I just created a few seconds ago. Let's do the same to the folder. Make clear fresh 0000. Of course, I cannot create a folder with the same file name. Cool. Now I have a freshly created file and a freshly created folder. Okay? All good here. So, but the permissions are different from the ones I created a few seconds ago. So these ones had this permission and these ones have these permissions. Why? Because when these were created, they had some permissions taken back from them, because the umask has done that for us. The umask has removed permission. I'm sorry for the noise. The umask has removed permissions from when the umask was set. If you check the default one, didn't I show you the starting point? I think we did, didn't we? Where is it? Where is my previous umask command? Didn't I do the umask before I reset it? I didn't show you guys. Because I'm stupid. But the default umask is 0022. Man, didn't I show you guys the umask before the change? Oh, it's there. I'm blind. Okay, there it is. So this is umask before the change. This is umask after the change. Okay. So what does this mean? Well, in order to understand what this means, let's kind of go back a little bit to these nodes. So here you have the binary method to set permissions. If you look here, which permission is worth 2? It's this one. It's the write permission. The write permission is worth 2. Okay? So if I go back here, since this permission is worth 2, this means that I'm subtracting the write permission from the original permissions. So this is kind of the before the change. Okay, this is after the change. So before the change, the write permission was there. Okay, so if I was using no umask, if the umask was doing nothing, this is what I would get on a file. This is what I will get on the folder. So if the umask was doing nothing, these are the de facto default permissions on the file and on the folder. So again, if the umask was doing nothing, these are the default permission, de facto default for a file. These are the de facto default for a folder. Okay, but the umask, the default umask is 0022. Which means it's subtracting the write and subtracting the write here. This is kind of the others, group, owner, and special permissions. Specials are set user ID, set user ID, set user ID, set group ID, sticky bit. So retract the write from the others, retracts the write from the group. Okay, that's why it's retracting the write here and from there. So after the umask is applied, which is applied always, you will subtract the group, the write on the group and the write on the others. Well, the other way around, of course. The write on the others and the write on the group. Okay? That's what the umask is doing. This is the default umask for every user on the system. It's 0022. That means that when I create a file, it's subtracting the write on the others and the write on the group. Since the folders start with a more broad permission, it's still subtracting, but the remainder, it's a little bit more wider, because the starting point it's bigger. So the default de facto permissions on the folder are full permissions, but we need to subtract on the others and subtract on the group, and that's why in the end they get these permissions here as the de facto final ones, and these are the de facto final ones for a file. So a umask is kind of subtracting from the de facto ones being for a file this one, the de facto ones being for a folder this one. So we have a bigger set of permissions as the de facto default ones, and this will subtract from those ones from the de facto broader ones. So let's set the default ones back, and let's say you put the 2 here too. So in theory, new files will be read. But I also subtracted the write from the user. So the umask allows you to set what are their default permissions, but bear in mind that the de facto ones are these for files and these for folders. So you are subtracting from this. These are the de facto ones. In my file system, some other file systems might differ a little bit, but this is kind of the generic thing to think. That is, these are the de facto starting permissions for a folder. These are the de facto starting permissions for a file. Okay? And then you will subtract from those. Okay? Let me just trace back a little bit, because I forgot to show you how can we change permissions of set user ID, set group ID, and sticky bit using binary method. It's easy to, you can just do the change command for the ch mode. And if you go round about this area here, somewhat here, there we go. So if you see the 4th permission for its group ID to its sticky bit, and I'm sorry, the first one is set user ID for, set group ID for 2 and sticky bit for 1. So if you see 4 permissions, it's like ch mode. Okay, that's got B, X, Y, Z. The B equals set user ID, set group ID, or sticky bit. Okay, so 4, 2, 1. Okay, and that's how you can set also the special permissions using the ch mode method. This was a long one. I know that it was. You really should read this, watch this again as many times as you wish. It's free. You can just rewatch it as many times you want to do so. Thanks for watching. Like and subscribe, it really helps. Ask any questions you may have on the comments below. I'm really happy to reply to any question. And I'll see you in the next one.